Hello seniors, today we're going to see electronic assignment 25, which is about the substitution method. I have already showed you what this is about in the previous electronic assignment, but we're going to reinforce that concept throughout this following exercises. You'll see it's actually pretty easy, and the substitution method helps a lot for finding integrals of different types of functions. So, objectives for today's class: calculate the indefinite integral of these functions. You already know the rules for each of these cases. Integrate the composite of any previous function with a linear function ax plus b. We saw this in the last electronic assignment. And finally, integrate by applying the method of inspection or substitution. Okay, so it says, we use the substitution method to evaluate integrals of the form, and we have this form. This is kind of like the chain rule, but for integrals, and you will see that it's very easy. It says the next example shows you how. So it says find the indefinite integral. So in this case we have the integral of 3x squared plus 5x to the fourth power, and all of that is being multiplied by another function 6x plus 5. So you see that in all of these cases, in part A, in part B as well, in part C as well, and in part D we have a division between two functions. Whenever we have a product or a division between two functions, you should automatically think about the substitution method in order to find the integral. As I told you, it's kind of like the chain rule, but we use it for integrals in this case, and it's not called the chain rule, obviously. It's called the substitution method. So let's see how this works. For part A, for example, we want to find the integral of 3x squared plus 5x to the fourth power, which is being multiplied by another function, which is 6x plus 5, and this is all with respect to x. Okay, so one thing we could think about doing is trying to expand this by multiplying the expressions, but since this is to the power of 4, trying to expand this first at the beginning would take a lot of time, right? And it's not the best way to go. We would rather use then the substitution method, which I already showed you how it works. But here it works once again. If I, for example, define this, the inner part of this function over here, if I call that u, let's call this u, we're going to make a variable change. So u is equal to all of that expression, 3x squared plus 5x. Let's see what happens when I find the derivative of u with respect to x. If I do this, I'm going to differentiate this expression, and this would be 6x plus 5. And you see that 6x plus 5 is exactly the same expression we have here. So maybe we're doing we're going through a correct path by doing this substitution, right? So if I leave dx alone because I want to replace dx with its equivalent expression, then I would have that du over 6x plus 5 is equal to dx, right? So now I'm going to replace the values. I'm going to replace u, which is all of this. I'm going to replace it right here. This is the equivalent expression of u. And I'm going to replace dx, this dx over here, by its equivalent expression, which is all of this, right? So when I do that, you'll see what will happen. If I rewrite that, then I'll have that this is equal to the integral of, instead of all that expression, I'm going to have u to the fourth power. Don't forget this fourth power we have right here. And this is being multiplied by 6x plus 5 times, and instead of dx, we're going to write its equivalent expression, which is what we have down there. So times du over 6x plus 5. So you see that we can simplify here the whole expression 6x plus 5, and we're only going to have the integral of u to the fourth power with respect to u. And we already know how to find that integral, right? If I do that down here, we're going to have that the integral of u fourth with respect to u is the same as saying u5 over 5 plus c. Don't forget the plus c. So that's it. But remember, we should always express our final answer using the original variable. So we need to substitute again u with its equivalent expression, which is in this case 3x squared plus 5x. So this would be equal to 3x squared plus 5x to the fifth power. This is being divided by 5 plus c. And this would be our final answer for this particular integral. So you see that in this case, we had to apply, there was no other option, we had to apply the substitution method in order to be able to find the integral. Or else we wouldn't be able to find the integral of this expression over here. Okay, so let's move on then to exercise B. Part B says the following. We want to find the integral of the cubic root of x squared minus 3x. So this is the cubic root. And this is being multiplied by 2x minus 3 dx. Okay, so once again, we need to try. The substitution method is a lot of experimenting, trying things. In this particular case, I see that it is convenient to rename whatever I have inside the radical as u. Because when I find the derivative of u, I'm going to get that this is 2x minus 3. And 2x minus 3 is exactly this expression I have over here. So let me call u our variable change. That's why it's called substitution method. We substitute an expression with a variable, right? So I'm going to call x squared minus 3x, whatever I have inside the radical in this case, I'm going to call this u. So if I find the derivative of u with respect to x, we're going to have that this is equal to 2x minus 3. And then if I solve for dx, we're going to have that du over dx is equal to, du over 2x minus 3 is equal to dx. So then I'm going to substitute once again, and I'm going to, all this part, let me do this with a bigger highlighter. All this part will be substituted inside here, the radical, and the dx, I'm going to replace all of this by this. Okay, so we're going to say that this is equal to the integral of the cubic root of u times 2x minus 3 times dx, where dx is this expression here, du over 2x minus 3. So once again, I see that we simplify 2x minus 3, and we just need to find the integral of the cubic root of u with respect to u. And this looks much more simpler and easier than what we had at the beginning. So to find this integral, I'm going to say that this is, remember, whenever we have a radical, it's more convenient to write it in the exponent form. This is u to the power of 1/3 du. So if I integrate this, I need to add the exponent plus 1. So this would be u to the power of 4/3 over 4/3 plus c, right? So then if I reorganize terms, we're going to have that this would be equal to 3 times, instead of writing u, I'm going to go back to the original expression, which is x squared minus 3x. This is all to the power of 4/3 divided by 4 plus c. And this would be the answer for this particular integral. Okay? I hope this is getting clear for you people. Now, let's move on to exercise. Actually, we need to do exercise C first. I'm going to take this down. Let's do exercise C. Exercise C says the following. I want to find the integral of x times e, the integral of x times e to the power of 4x squared plus 1 with respect to x. Okay, so once again, I see there's a product between two functions, right? Function x and function e to the power of 4x squared plus 1. So since there's no chain rule or product rule or quotient rule for integrals, I need to think about substitution method. So what do you think I should substitute in this case? Well, as I told you, this is a lot of experience and practicing with exercises. But I see that in this particular case, I need to replace this exponent with the variable u. Okay, so I'm going to make that variable change. I'm going to say that u is equal to whatever I have in the exponent, in this case, 4x squared plus 1. Because when I find the derivative of u with respect to x, we're going to have that this is 8x, right? So if I solve for dx, we're going to have that du over 8x is equal to dx. Right? So then I'm gonna plug in all of this information into my equation. So this would be equal to the integral of x, I'm gonna leave it like that, times e to the power of u instead of 4x squared plus 1. And instead of dx, I'm gonna write its equivalent expression times du over 8x. So once again, we see that we eliminate the x and we are able to find the integral. That's a very important thing that you should remember. If you in this case, for example, were left with an x and you are integrating with respect to u, then that means that there's something that you're doing wrong. Whenever you're integrating with respect to a variable, you should never have left behind any other letter which is not u, okay? So that's something very important for you to consider. So this is the same as saying the integral of EU. Actually, this is the same as saying I can take this 8 out of the integral. So this is 1 over 8 times the integral of e to the power of u du. Okay, so the integral of e to the power of u is e to the power of u. So this is 1 over 8 times e to the power of u plus c. Please don't forget the plus c. So once we have found the integral, I need to replace my variable to its original state, which is in this case 4x squared plus 1. So finally our answer would be 1/8 times e to the power of 4x squared plus 1, and this is all plus c. And this would be our final answer for this example. Okay. Finally, we're going to see one last example, part D. I had that one down here. Part D says the following. We need to find the integral of 12x cubed minus 3x squared over 3x to the 4th power minus x cubed with respect to x. Okay, so as I told you, we do not have the quotient rule for integrals. So I have a function which is being divided by another function. But since there is no quotient rule for integration, I need to apply substitution method, right? Which is the method we're learning today. Now, in order to decide what I will be calling u, the variable change, I should look at the degrees of both functions. I see that, for example, the function above, has degree 3, right? Because it's x cubed. While the one below is degree 4 because it has x to the power of 4. So maybe it'll be more convenient to call this expression u, because when I find the derivative of that, I will maybe getting this, because remember that the degree of the function decreases whenever I find the derivative of that function, okay? So that's exactly what I'm going to do. I'm going to call u the function in the denominator because it has a greater degree. So this is 3x to the 4th power minus x cubed. So if I find the derivative of u with respect to x, then I'm going to be getting as a result 12x cubed minus 3x squared. And you see that this is exactly the same expression we had right here. So that means that we are going in the right path, okay? If you tried calling this u instead of this, you would see that you will be getting another result for du over dx, and you wouldn't be able to solve this using the substitution method. Okay, so if we reorganize this, we're going to say that du over all of that, 12x cubed minus 3x squared is equal to dx. Okay, so once we have done all of these changes, we're going to apply the changes to the integral. So this is the integral of 12x cubed minus 3x squared divided by u. We change all of the denominator by u according to this, times dx, but instead of writing dx, we're going to write this whole expression. So times du over 12x cubed minus 3x squared. So I see that we can simplify all of this expression. All of this simplifies with this. So we're only left with the integral of 1 over u times du. And if you remember from previous classes, the integral of 1 over u is natural logarithm of u. So this is the same as saying the natural logarithm of u plus c. But once again, remember we need to go back to the original state of the function. So instead of writing u, we need to write this expression here, and then we're done. So this is the natural logarithm. Actually, I'm going to change my L. The natural logarithm of u plus c. So this is natural logarithm of 3x to the 4th power minus x cubed plus c. And this would be our answer for part D. Okay, so these are kind of simple exercises for the substitution method. Later on, you're going to be practicing with more, but I think it should be clear for you people. So that's it. Yes, I think that's it. Yes, that's it for today's class. So I hope this was clear. If not, please let me know.